In this data-driven engineering tutorial, we're going to be talking about similarity search. And this is going to be useful with RAG applications, retrieval-augmented generation for large language models in particular, but it could also be searching through a document database of relevant context for a particular query. So it's like setting up your own search engine among all of your documents. So you might have, for example, PDF files, you might have text files, there might be Q&A from customer feedback or prior help sessions. All of these are going to be documents that we're going to load. And we're going to parse them and split them into this, text splitters. We're going to show an example of how to do that, to parse these into individual elements that we're going to then feed into an encoder model. Okay, so the encoder model, we're going to then take this and encode them into vectors. Okay, so the words and the sentences are going to come into this encoder model, and we'll store those efficiently for search. And this is going to go into a database. Okay, so here's our database of values, and we're going to use ChromaDB throughout this whole process to be able to feed these vectors into our database. And then later on, if we have a large language model, what we're going to do is we're going to have a query, okay, and this is going to be a question or something that we want to be able to retrieve similar vectors from this database or similar sentences in some sense. So that's going to return with a k-nearest neighbor search. Okay, the similar search. So this is our similarity search. Okay, similarity search that then we're going to use for maybe our top, let's say that's 3 documents that we've searched, and then that is going to be fed in as context for a large language model. Okay, so this might be our large language model, and that's going to be our context, and we have a question that we're also going to feed in. Okay, question, and that question is also going to be the query that is able to retrieve those similar questions so that we can feed in the context without necessarily fine-tuning the large language model. Now, another approach for this is to take all of this information right here and do fine-tuning, where we might modify parts of the large language model, okay, and those might be fine. This is going to be fine tuning, where we adjust some of the parameters, with an approach that identifies certain layers or certain parts of the large language model to be able to fine tune it without necessarily adapting all of the parameters of our large language model. But for today, we're going to focus on this first part right here, just this database, and doing some sample queries just to be able to retrieve the information from this vector database and set that up with ChromaDB. Okay, so let's jump into this. If you'd like to follow along with the code, come to this address right here, and you'll see a Google Colab notebook as well as it's stored on GitHub. And so you can download this and then start running the code. So I'm going to go through this exercise. And the very first thing that we're going to need to do is pip install. And we need to get ChromaDB and also make sure we have pandas. Now, pandas is most often included with a Jupyter Notebook environment. So just make sure you have both of those, and you only need to run this once. So once it's there the first time, you can comment that out. You don't need to run it again. It's already installed. So we'll let that one finish. The next step is going to be to import the modules and read train.jsonl. Okay, so that's a import. We're going to import pandas as PD, and we'll also import ChromaDB. And then we want to be able to read the Gekko LLM training, training data. Now, let's see, that just finished, installed all of those dependencies. Let me go ahead and just run this again so it removes that. Okay, so that is installed. Okay, so let's go ahead with reading the Gekko training data. We'll get the URL. Now this one is going to be GitHub user content, the raw file, and the path is going to be here in BYU-PRISM, Gekko, master, and docs. This is going to be LLM train.jsonl. Now, if you want to look at it, here is the file. There's a number of questions and answers about Gekko. Okay, and everything in here all the way down to question number 542. Can you simulate a hyperbolic PDE in Gekko? So all of these are going to provide context for the Q&A chatbot. And if you'd like to access just a trial of this, come to APMonitor.com/docs. Okay, and I'll just say, what are you trained to do? Okay, so it's going to use this data, these 540 example questions and answers, find some of them that are similar, in this case 5 that are similar, and then create a customized answer. So in this case, we don't need to do fine-tuning of the Mixtral model. In this case, it just searches for similar questions and then crafts that new answer with the context from the similar questions. Okay, so we're going to go back here. Okay, after this, we're going to go ahead and import. Okay, there's our path and URL, and let's go ahead and also load that in. We're going to read the JSON file. We'll do url+path, and we'll say lines equals true. Okay, so when I read that in, if I insert a new cell below, that's going to be a data frame with all of my questions and answers. Okay, and you can see it goes down to 541. All right, now these are hundreds of questions about Gekko. We don't want to provide all of those as context. We just want to provide just the most relevant. So what we need to do here is go ahead and create a list of documents. This is going to be the text. We need metadata as well, another empty list, and then some IDs. Okay, and that's going to be able to store it as the vector database. We're going to go through all of the rows of that data frame. Okay, the Q&A data frame that we just created. And we'll first of all create our formatted string that's going to include the question. There's our question. And then also our answer as well. Make that a little bit smaller just so we could see it. Okay, so we're going to put this into a single, this is going to be a single list item that then I'm going to be able to feed into this vector database. Okay, then I'm going to have documents. I'll append to that, this string. And then I have metadata as well. And I'll just call that question ID. And I'll make that question ID underscore I. So it's going to be 0, 1, 2, 3, 4. Okay, I also have IDs here. And that's just going to be the string of the number as well. Okay, so I'll put all of those. I'll make 3 lists of documents, metadata, and IDs. Okay, next we're going to read the training data, process it, and then use the ChromaDB to create the vector store. So let's go ahead and just store in memory. Now we can also store on the drive, on the local drive or in another location. But for this case, let's just create a local client that's just going to run this in RAM. So we're not going to store anything on the device. I'll show you some code to be able to store it as on the device. If that vector store takes a long time to build, you may want to process out once and then store it in a database that's local. Okay, I'm going to create a new collection. I'll call this MyDB. And I'll add to that my documents, my metadata, and my ID values, and go ahead and run that. Okay, so now this is the process where if it's the first time you've run this, let's see if it shows it here. Okay, it doesn't show it necessarily, but the very first time it's going to have to download a very small language model. In this case, I think it's about 90 megabytes in order to be able to vectorize all these sentences. So if this is the very first time that you've run this, it might take a little bit just to download the LLM that's going to process this into vector form. Okay, all right, so here we go. For large documents, it takes a lot of time. Okay, so if you need to, come to this link right here, and down here it shows how to store it locally. Okay, if you want to be able to create the collection and then save that, okay, a persistent client instead of just a client. I also turn off the anonymized telemetry so it doesn't send any data to the ChromaDB developers, but you could leave that on if you'd like to send that. Okay, so back here, the final step now is to go ahead and get some results. I'm going to do a query on my collection, and my query text, what are you trained to do? Okay, I'll get 5 nearest results, and also include the distances and the documents. So these are going to be the k nearest neighbor distances. If you'd like to get more information on k nearest neighbors, there's a link to that on how k nearest neighbors works, and the algorithm if you need more information from the machine learning course. Okay, so there are my results, and then finally I'm just going to print the results. So let's do this. Let's do just the distances first of all. So we can see the distances. Okay, I have 1, that's going to be the closest one, 1.3, 1.4, 1.5, 1.5. So the closest one is going to be this very first one right here that it retrieved. So let's go ahead and just get that. Okay, what are you trained to do? So here is a question, what are you trained to do? So it found that one first. It's an exact match to the question, and there is the answer as well. But it also had a few other relevant related questions as well. So you can see that the similarity score wasn't quite as high, but it included those as well for additional context for the large language model. So let's come down here and just show an application of this. We're going to build all of this in the pipeline to be able to run this locally, but here is a cloud-based solution. So I'm going to do from Gekko import support, and if you need to download Gekko, just say pip install Gekko, and if you have a version there already, just do -- upgrade to be able to get the latest version of Gekko. Now, there's a little bit more information about this. Okay, so successfully installed that. And I'll go ahead and comment this out. All right, and then run this again. I can ask a question. Okay, what are you trained to do from this support agent? All right, so I showed the web interface for that before. Now here is the way to run that support agent from the command line to be able to get a relevant answer based on those questions in a RAG-supported large language model. Okay, so there's the snippet to access the Gekko vector store and RAG to provide context to the LLM. So here's the activity that you can do. Generate a Q&A similarity search. Go ahead and put in your own questions and answers right here, and then build the vector database and perform a similarity search using my database.jsonl file instead of the Gekko Q&A. So to do this, we're just going to go through this as a review. We're going to read the data. There's our path, mydb.jsonl. Okay, JSON-L is a little bit different than a regular JSON file because it doesn't have the commas that separate. It has a little less structure to it. Each line is a separate entry. Okay, and we just need to include lines equals true here when loading it in. Then I'm going to read that in as question and answer in that same format that I did before. I'm going to create a collection just in memory. You could do that on your disk as well. Okay, I'm going to add documents to that. Okay, it's going to vectorize it and add it to the database. And then here's a question to test the similarity search. So you can add another question to test the similarity search and then run that and determine how well it does. So go ahead and create this JSON file right here and then run this code to do the similarity search. You can adjust this to say 3, or you can do 10 or 2, any number of those as well. The other thing that's going to be very valuable is this distance metric. As you do your RAG-enabled LLM, maybe you cut off queries, you have retrieved maybe 20 of the most similar, and then you cut off the ones that are above a certain distance metric to the one that you're interested in. So there's a lot of different ways to do that. Also, I'd recommend looking at LangChain. There's others that help to automate some of this flow of information with chain of thought or other things where you might want to build more sophisticated large language models. But this is just a very basic introduction about how to use ChromaDB locally to create the context for RAG-supported LLMs.